So let's just try to apply the concepts of nodal analysis that we learned in the last video to this practice problem. So let's start off by identifying all the nodes in the circuit. So I can just start off by marking the nodes. This is node A, and this is node B, and this is node C. So I have to choose one as a reference node. So I can just see which node has the most branches, and node all of these nodes, they have the same number of branches connected to them. So I just assume that node C is the reference node, and that won't really make a difference if you choose node B or node A. Any node can be the reference node. So because node C is the reference node, we need to find VA, we need to find VB, where VC is 0 volts. So we'll just start off by writing the KCL equations, KCL at node A. So there is clearly this 15 amps current entering, so there's plus 15. Then there is this branch 1 ohms, but as we use the convention that the current is always entering the node that we are considering, so the current will be flowing here. So this will be positive and this will be negative. So we'll just see VB, the other node, minus the node that we are considering VA. This is divided by the resistance. This is clearly Ohm's law. And then the same goes for this branch too. There's a current entering, so plus minus. So there must be the other node minus our node divided by the resistance, and this is equal to 0. We'll just write the KCL at the other node too. Don't worry about this dependent source. I'll tell you how to deal with it later. So there is this 3I1 entering, and then there is this 3 ohms branch, and we'll just assume that the current is coming from the other node, that is VC minus VB divided by 3. And then there is this 1 ohms branch, and this time we'll assume that the current is coming here, so this will be positive, this will be negative. So plus VA minus VB divided by 1, and that's equal to 0. Now we have our nodal equations, but there's a problem. We can clearly see that there are three unknowns. There is VB, there is VA, VC is 0, so just ignore that. This is 0 too. But there's this third unknown, which is I1. So we have three unknowns, but just two equations. So we need a third equation. So the way you can just get the third equation when there are dependent sources involved is by looking at the quantity that they are dependent on. So for example, right now, we need to find an equation that links I1 to our nodes. So we can clearly see that I1 is the current coming from VA to VB, up to down. So that means that VA has a positive direction and VB is negative. So I can just say that I1 is equal to the voltage difference divided by the resistance it is passing through, which is 2. So I can write I1 as this VA minus VB divided by 2, because as you can see, I1 is nothing but the current through the 2 ohms resistor coming from up. So that would be the positive terminal, that would be the negative terminal, and this would be the resistance. So this is how you can deal with dependent sources. And now if you plug it in to this equation here, you will get I'm sorry, I just made a mistake. This is VC, because this is clearly node C. I just made a typo, but I can say that that means VA minus VC divided by 2. So now I have two equations and two unknowns, VA and VB, and now I can just use simultaneous equations to solve these, and the answer comes out as, so solving those simultaneous equations, they give me this answer, which is VA is minus 40 volts, VB is minus 75, and VC is 0 volts. So whenever you are dealing with dependent sources, just write down the simple KCLs for each node except the reference node, and for the last equation, just link the quantity that the sources are dependent on with something, and then something related to nodes. So that is how you can get to the answer. And I hope this makes things a little more clear about how to use nodal analysis with dependent current sources involved.